Happy Monday, guys, or Tuesday, depending on which day you're watching this. So today's lesson's not very long. However, you are going to have a Hawks assignment at the end of this. I'll kind of go over some of the problems that are on it. So we're still working with systems of equations. However, we're going to talk about graphing them instead of solving them using substitution or elimination. So if you don't like substitution or elimination, you can always graph the problems to solve them. The easiest way to do that is to get them into y equals mx plus b and then see if they intersect. So this one right here, both of these are already in y equals mx plus b. So I would graph the first one, my y-intercept's 2. Then I'm going to go down 1, right 2, down 1, right 2, down 1, right 2, and so on. Or I can go up 1, left 2, up 1, left 2. And it's kind of hard to graph on here, but you guys get the general idea. The other one I can go up to 7, then go down 3, left 4, until you get to the point that they intersect at. Again, you can always type these in on Desmos to graph them, and you could get -4, 4. Don't forget, you can always double check it. I can plug the x in, the y in, and see if it works. So 4 equals -1/2 times -4 plus 2. It checks out. It needs to work for both of them. I'm just going to do the first one to show you how you check it, though, and then you would go on from there. So again, you're just going to convert them to y equals mx plus b and solve them. So this one I would subtract the 5x over, subtract my 6y over, and divide by -6. This one, all you have to do is divide by 2. Again, you can graph these. However, you can also use elimination or substitution. And this one, graphing kind of gives you a weird answer, so it's best to use elimination or substitution. When you solve it, you get decimals, which is kind of hard to graph. So don't forget that those are still options. So I'm not even going to graph number 2. Number 3, same thing. I just need to convert the equations to y equals mx plus b and solve them. So I'm going to add my 2y, subtract my x, and divide by 2. Same way here. Get it to y equals mx plus b. Now here's the thing. These two, their slopes are the same, but their y-intercepts are different. So if you have same slope, different y-intercept, they're never going to intersect, which means there's no solution, which means it's inconsistent. Last one I'm going to let you guys do. I'll put a question in here in the video. You guys can graph it. You can use substitution or elimination, but I just want you to solve it and see if you get the answer right. So I want you to do this problem right here. And then lastly, there are some word problems. I do not think they are super difficult. Kind of just depends on how you think about these word problems. The easiest thing to do is to read it and then label your x and y, because every equation is going to have an x and y because we're talking about systems. So it says a new restaurant is to contain 2-seat tables and 4-seat tables. Well, right there, my x is the 2-seat tables, my y is the 4-seat tables. Now it says fire code limits the restaurant's maximum occupancy to 56 customers. Well, 2-seat tables is 2 people, plus 4-seat tables is 4 people, equals 56 people, 56 customers. So that's one equation. Now, a linear system, you need 2 equations, so you have to write another one. Well, then it says if the owners have hired enough servers to handle 17 tables of customers, well, x plus y, my tables, is going to equal 17 tables. And now you can solve it. The easiest way to do it is elimination or substitution. On this one, I'm going to use elimination, so I'm going to multiply this one by -2. So I'm going to keep my top equation the same, change my bottom equation, and then solve it. So I got 11 four-seat tables, and then I'd plug that back into this equation right here. X plus 11 equals 17. I have 6 two-seat tables. And today you solved it. So that's just an example of what it's going to look like. I'm going to skip 6. Number 7 is really what you're going to see on the Hawks for the most part. So they give you two accounts. The first account, you need to know the 8%. The second account, which is a stock fund, you need to know 7%. So it says, we're going to use a linear system, so you have to write two equations. It says the investor puts $700 more in the first account than the stock fund, and at the end of the year finds that the total interest in both investments totals $1,400. So he wants to know how much money was invested at each of the two rates. Here's what you have to do. So the first equation I'm going to write is I'm going to label my X as account 1. I'm going to label my Y as stock fund. So it says he puts $700 more in the first account than in the stock fund. So I'm going to take my first account, subtract 700, and that's going to equal the stock fund account. So that's one equation. Now it says the total interest from both of them, whenever you add them together, is going to be $1,400. So I'm going to take my interest rate, make it a decimal, and set it equal to the total amount. Now you can use substitution or elimination to solve these. I'm going to use substitution. I'm going to plug that in for the y in the other equation. So I'm going to solve it like this. $1.5x So X ends up being $9,660. You'd plug it back in and solve for Y. And that's how much he invested into both of them. Make sure you keep it straight. This is account 1. This is your stock fund. So just as an example, that's what the Hawks is, guys. Is you're going to do that. You can always double check it. I could find the interest of both of these. So I could do 9,660 times my 0.08 and add it to my 8,960 times 0.07. And you should get the interest amount that you have. And it works out on that one that we just did. So I'm not really going to do any of the Hawks. Just make sure you know how to solve them. So this is the same equation we just did, guys. You're going to use that last one quite a bit. Number 2 is just solving the system. You can use substitution elimination or graphing. It's kind of up to you. Consistent means there's going to be one answer. Inconsistent means no answer. Dependent means there's infinitely many. So again, some examples of this. No answer would be like 0 equals 3. Dependent would be 3 equals 3. Consistent is going to be like x equals 2, y equals 3. So most of the time it's going to be consistent. It just depends. But yeah, that's it. That's the Hawks. So it's 10.1. That's your homework. If you have any questions, please send me an email.